What's up, all you badass mathematicians? So today we're going to talk about limits and really try and figure out what exactly is a limit and why is it useful in calculus, and why is this the fundamental, basis of calculus and everything we talk about in this subject. So what I would define a limit as, I'd say a limit is a property of a function that gives info about the function's behavior. And now here's a keyword: around a specific point. Now, around a specific point. Now, this is very specific in that some people, I feel a common confusion is you might see someone say it's at a specific point and telling you something that's happening at a specific point, when in reality a limit is actually describing the behavior around the point, what happens as you're approaching that point from different sides. So whenever we're talking about limits, we're not really talking about what's happening exactly at that point. So we're not really care about the actual value of that point. So don't really care about f of c for some c in the domain of our functions, but rather we care about what's happening around c. We care around x equals c. So if we were to actually try and visualize this, and here's some function, and let's say this is 4 and this is 4. So one question when trying to figure out the behavior of this function, we might ask, what's the limit? And let's say that this is some function f of x. We won't actually give this function a name. This will just be more generalized. So what's the limit as x approaches 4 of f of x? So again, I'll go over how to read this. So this right here is saying, what is the limit as x approaches 4? So as our x values approach near 4, of our function f of x. So in this case, our answer here would be 4. And now let me draw another example. This is going to be the same function but slightly different. So now let's call this g of x. This is still 4. This is still 4. But now in g of x, note that 4 actually isn't in its domain. Meaning, if you were to plug 4 into our function g of x, you're actually not going to get a value back because there's this hole here. In other words, the domain of f of x is all x values greater than or equal to 0, whereas the domain of g of x is all x values greater than or equal to 0 except for 4. So now we can ask the question, well, then what is the limit as x approaches 4 of g of x? Does it simply not exist? Well, in this case, we'd actually also still say that it's 4. And so I would say that this example is really important to illustrate why this keyword around is so vital. Notice in both of these cases, one where f of 4 didn't, or I should say g of 4 did not exist. In this case where 4 was actually a part of the domain, the limit still exists and the value of these limits are still the exact same value. So now another example. Well, I would say a good question to ask next would be why are these limits the same despite 4 not being in the domain of one of the functions? And so now we're going to go into what exactly and when does a limit exist. So when does a limit exist? And in the next video, I think going through a lot of examples will be really helpful to kind of pinpoint exactly what this idea of a limit is. So a limit of a function f of x will exist if and only if, so the limit as x approaches c from the right of f of x is equal to the limit as x approaches c from the left of f of x. So now this is additional notation. So how to read this? It'd be the limit as x approaches c from the right of f of x is equal to the limit as x approaches c from the left. Sorry, I keep getting confused of f of x. So it's really important to get this notation down. So to illustrate this, what we're actually looking at when we're talking about the limit as x approaches c from the right, it means from our point of interest, which in this case will be 4, we're going to be approaching this value from the right hand side. So we're trying to figure out what value we're approaching as we approach from the left. Similarly, when we're talking about the limit as x approaches c from the right, we're going to be approaching it, from the left, we're going to be approaching from the left side. So if these two values seem to be in agreement on where they're headed, so in this case the y value 4, then we can say that the limit exists. And this really makes it a little more clear on why we don't specifically care about the value of f of 4. And when we're looking at g of x, even though the value 4 is not in the domain, we were still able to establish that the limit exists, and that limit is actually 4. So thank you for watching. I hope this was a good exposition. We'll be making follow-up videos to go into other examples to really drive home what is this limit, when does it exist, and when does it not exist.